is 0. Means what happens, this was the condition at 0 degrees. Now it has completed half revolution, half rotation of 180 degree a dash. At this instant again the coil is in the horizontal plane. It is, what is the rate of change of flux linking with the coil is 0. So at 180 degrees again we have EMF induced equal to 0. Now after 180 degrees again it moves further, it starts rotating further from 180 to 270 degrees. So in this case what happens, earlier when it was the coil, when it was rotating from 0 to 180 degrees, this coil was under the influence of the north pole, right? Now when it has come in this at 180 degrees, rotation is completed. From 180 degrees it starts rotating again further in the counterclockwise direction. So what happens is, in this case the coil has started coming under the influence of the south pole. So what will happen, again in this position the coil a dash, the flux linking with the coil was maximum, but rate of change of flux linkages was 0, so EMF induced was 0. But now it is coming under the influence of the south pole. Again the rate of change of flux linking with the coil increases. Your d phi by dt is increasing, but in the reverse direction, in the negative direction, as you can see from the waveform. Why? Because alternatively your coil is passing under the influence of north and south pole for every half rotation, right? So if a positive polarity was existing when it was under the influence of the north pole, so a reverse polarity will exist for the other half rotation, right? So your EMF will start increasing. There is an increase in value of EMF because d phi by dt is increasing, but in the reverse direction. So your EMF is reaching its maximum value, but in the negative direction when it covers a distance of from 180 to 270 degrees. So what do we have here? From 180 to 270 degree the EMF induced is increasing, negative value, and it comes to its peak value at 270 degrees. Again now what happens, your coil has further completed rotation of 90 degrees. It has come here, the coil is in this position, that is a dash, right? Now from here again maximum EMF will be induced because rate of change of flux linkages is maximum. Then further rotation, what will happen, from 270 to 360 degrees, or the starting position, what will happen, like the rate of change of flux linkages decreases. So because the rate of change of flux linkages decreases, from here the value of EMF starts decreasing till it completes the rotation and it comes to 360 degrees. So what do we have, from 270 to 360 degrees of rotation, again a 90 degree of rotation, what will happen, the EMF induced in the coil reduces. So what we have got, so for one complete rotation, a coil completes a rotation, it passes under the influence of north and south pole alternatively. So we have positive cycle of the wave and the negative cycle of the wave. Our voltage starts 0 initially at t is equal to 0 or theta is equal to 0. It increases, reaches peak value, it further drops, comes to 0 degree, at 0 EMF at 180 degree, then again it increases to its peak value, the maximum value, and again it decreases and it comes here. So one complete cycle of rotation the coil completes, we get one cycle of sinusoidal wave of EMF induced in phase A or coil AA dash. Now we have, this is we are talking about 3 phase here, right? So what do we have? We have 3 coils. Along with AA dash, the coil BB dash and CC dash is also rotating. They are mounted on the same shaft, right? So when the coil AA dash is in this position, what is the position of coil BB dash? It is at a displacement of 120 degrees from AA dash. So in this position, what will be the EMF that is induced in coil BB dash at the instant theta is equal to 0 degree? VA is 0, but what will be the value of VB? Now VB is as you can see, the position BB dash, it is here, it is 120 degrees lagging behind AA dash. So, and under this position, obviously the coil BB dash is cutting flux, means there is a rate of change of flux linking with the coil, but it is again, as we said, if it is under the north pole, the EMF induced will be positive. Under the influence of south pole, if the polarity will change, so some EMF will be in this position, some EMF will be induced in coil BB dash, but in the negative direction. The polarity will be negative. So as we can see, when VA is 0, coil BB dash, in coil BB dash there is a rate of change of flux, right? So some EMF will be induced, but it will have the negative direction, and it is moving from the the rotor is rotating in the counterclockwise direction. So as AA dash start rotating, BB dash also is rotating. So when it comes under here at this point, so your coil BB dash is in this position, rate of change of flux linkage is maximum. So maximum flux EMF is induced in this coil, right? Then for further rotation, that is from this instant to here, what will happen? The rate of change of flux linkages decreases, the EMF starts decreasing, and when it starts decreasing, when it comes to this position, that your coil BB dash is in the horizontal plane, the rate of change of flux linking with this coil is 0. So what will be the EMF induced? 0. So this is 120 degrees. It has covered a distance of 120 degrees till here. So when it has covered a distance of angular displacement of 120 degrees in the counterclockwise direction, in this position the EMF induced in this coil will be 0, right? So as we can see, right, from this waveform, if we compare, when VA is 0, there is some EMF induced in coil B, but in the negative direction it starts increasing and it comes to 120 degrees. So from this we can say that the voltage that is induced in coil B is lagging behind the voltage that is induced in coil A by 120 degrees. The voltage is lagging behind the voltage VA by 120 degrees. Then for further rotation, again as it goes, the waveform will be similar to this, that is from this point it has covered a distance of 120 degrees, then from 120 degrees again for the 90 degrees, when it covers, what will happen? The EMF, the rate of change of flux linkages will start increasing, and rate of change of flux linkages start increasing means the EMF induced increases, so it starts rising in the positive direction. So when coil BB dash is in this position, we have maximum voltage that is induced in the coil BB. In the coil B, that is VB, we will have the maximum value when the coil is in this position. Then for further rotation of 90 degrees, what will happen? Here the rate of change of flux linkage is reducing, so the EMF will decrease in the coil, the EMF induced decreases, and when the coil BB dash is in this position, the EMF induced is 0. So again, when the coil completes 180 degrees of 180 degrees from here, what will happen? Right, 120, 90 degrees of rotation maximum, and then further. So what will happen? We get the positive cycle of the sine wave. Now from here, when the coil is in this position, it starts again. The coil is rotating in the counterclockwise direction. It is coming under the influence of the south pole. So again the polarity reverses, and polarity is reversing means the EMF induced reverses. It goes towards the maximum negative value. It comes when the coil is in this position. Then again it continues, right? It follows again the EMF induced. Obviously it will follow the sine wave. So here from we get the positive cycle of sine wave in coil BB. But if we compare the two, right, we can see that always the voltage that is induced in coil BB is lagging behind the voltage that is induced in coil A at any instant by 120 degrees. Now this coil C dash, again when it is also rotating, the three coils are rotating together in the uniform magnetic field, it's mounted on the same rotor. So at this instant, that is at theta is equal to 0 degree, when the voltage induced in coil A, that is VA, is 0 degree, what is the voltage that is induced in coil CC dash? Coil CC dash has just, this is the position for maximum voltage, right? This is the position at which we have maximum rate of change of flux linkages. So this coil CC dash has just passed it. So it has just passed the position of maximum voltage. When the coil AA is in this position, coil BB dash is in this position, and CC dash is in this position. And we know that C is 240 degree behind VA, or it is 120 degree ahead of coil AA. So what will be the EMF induced in coil CC dash? In this position, it has passed its position of maximum voltage. It is coming towards the horizontal plane, so the EMF tends to reduce. So but because it is under the influence of north pole, which we have taken as a instant of positive polarity, some EMF will be induced in coil coil C dash, which will start decreasing, because we are coming in this position where the horizontal position means the position of zero voltage, rate of change of flux linkage is 0. So the voltage starts decreasing and it comes to 0. So how did we get the 60 degree? This coil is leading coil AA dash by 120 degrees. So this is 90 degrees. What is this angle? It's 120 minus 90, that is 30 degrees. So what is left here? This is 60 degree. So from this instant, when it comes to, it has traveled an angular displacement of 60 degrees, the EMF in coil CC dash tends to be 0. Means your coil CC dash is in this plane, that is the position for 0 volt, position of the coil for 0 voltage. Then from this position, it starts rotating again in the counterclockwise direction. It covers a distance of 90 degree. The voltage, again it is coming under the influence of the south pole here, so the polarity of the voltage reverses, means we get the negative cycle here. From this instant to this position, that is what will have, the voltage starts decreasing in the negative direction. It comes to, when the coil covers a rotation, it reaches here, what will happen? A voltage that is induced, maximum voltage, because rate of change of flux linking is minimum, but rate of change of flux is maximum. Now from here, again for further rotate, the coil is rotating further in the counterclockwise direction. The voltage starts increasing till it comes to 0. At this instant, this is the position coil CC dash, it comes here, your voltage reduces to 0. The negative cycle we have got, right? Then from here again, if we start rotating it, again it is coming under the influence of the north pole. Rate of change of flux linking the coil CC dash increases, so the voltage starts increasing. It comes here, when it comes here, the maximum voltage is induced in the coil. Then for further rotation, the voltage starts decreasing, and so on. So so at the same instant, the 3 coils are mounted on the same shaft. They are rotating in counterclockwise direction. EMF is induced in all the 3 coils, and that is how a 3-phase EMF is generated. Let's consider 3 waveforms together. Right. Say we have coil. Right. So what do we have here now? The 3-phase EMF has been generated, right? At theta is equal to 0 degree, your VA is 0, it is increasing to its maximum value, reducing, coming to 0 after 180 degrees of rotation, and then the negative cycle. At the same instant, your voltage VB is lagging behind VA by 120 degrees, but in the it is increasing towards the maximum value, but in the negative direction. Then it starts decreasing, it comes to it comes to 0 and then it further increases. At the same instant, the voltage across coil C, that is VC, has just passed through its maximum value. Some EMF is induced in the coil VC. It is decreasing. It is coming to 0. Further it's decreasing. It's reaching its maximum value in the negative direction. Maximum peak value negative. It's decreasing. Again coming to 0 and so on. So as you can see, right, your voltage VB lagging behind VA by 120 degree, voltage induced in VC lagging behind VB by 120 degrees, but from VA it is lagging behind by 240 degree. We always take the reference as the VA is taken as reference, and with respect to VA we show the phase displacement or angular displacement, or the angle by which the voltage is lagging in each phase. The phasor diagram, as you can see, right, this is a phasor rotation. Your phasor is rotating in counterclockwise direction. This is the voltage, that is the vector which shows the voltage induced in phase A. This is VB, which is lagging behind this voltage wave by 120 degree. This is lagging behind VB by 120 degree, that is VC, but from VA it is 240 degree, or it is leading VA by 120 degree. So what did we see, right? That when the coils are rotated in the counterclockwise direction or anti-clockwise direction at a constant angular velocity at omega radian per second, a sinusoidal voltage is generated in each coil. And as the coils are rotated at the same velocity, right, what is velocity? Omega is equal to 2 pi f, so the generated voltage will have the same frequency. And also, as the coils are identical, the generated voltage just in each coil will be same. It will have the same magnitude. Only thing is that there will be a phase difference of 120 degrees between them, which we just now saw in the phasor diagram as well as the waveform. So now let us derive the equation for voltages that is induced in coil. Suppose VA is the voltage that is induced in coil AA dash, VB is the voltage that is induced in coil BB dash, and VC is the voltage that is induced in coil CC dash, and we take VA as the reference. So from the phasor diagram we just now saw that VB is lagging behind VA by 120 degrees, VC is lagging behind VB by 120 degrees, or it is lagging by 240